here is the derivation for the diffraction grating formula. We start with just a general diagram of incident light hitting a diffraction grating. Each of the slits in the diffraction grating allow the light to diffract. They behave as coherent sources, and the coherent sources interfere with one another and form an interference pattern. What I have on the screen is just an example interference pattern. In reality, you might have 3 bright dots or fringes. You could have 11, you could have 13, but you'll always have an odd number. In this case, I just have 5 of them. And what the n equals 1 represents is the light from one of the sources is out of phase by 1 wavelength from the adjacent source. So the light from one of the slits is out of phase by 1 wavelength from the adjacent slit. What n equals 2 represents is that the light from one slit is 2 wavelengths out of phase with respect to the light from the adjacent slit. What n equals 0 means is that they're perfectly in phase, so there is no shifting, or the light from adjacent sources travels the same distance. Coherent sources just being sources with the same frequency. Alright, so let's have a look at n equals 1. So the dotted black line will represent a horizontal line, which would represent the straight through. And then the 3 parallel red lines represent a beam for n equals 1. What we're going to do is highlight the circled part there, like so. And again, we have the straight through line representing n equals 0, and we have the red line representing the beam of n equals 1. Now, I draw a line from B to C. That line is perpendicular to the red beam at the top. And what happens then is we have 2 lengths in this right angle triangle. The first one is the distance between 2 adjacent slits is called D. Now, the reason we draw that perpendicular line in is because if interference occurs, constructive interference occurs, then the light traveling from A and from B are in phase, or there's a constant phase difference of 1 whole wavelength. What I mean by a phase difference is one of them is shifted or has to travel a wavelength more in this case. So the length AC is a full wavelength. Now, the angle where C is, so C is actually a point, but the angle between the red line and the horizontal is the angle theta. And you can use simple trigonometry to show that if that's theta in there, the angle labelled inside the right angle triangle is also theta. So when you use the sine of theta, it's opposite over hypotenuse, which will be lambda over d, and then when you cross multiply, you get lambda is equal to d sine theta. I don't have the theta symbol here. So what we get is, for the first order, the formula 1 lambda is equal to d sine theta. Now we're going to repeat. So for n equals 2, again, we'll have the horizontal line representing the straight through, and we have the 3 red lines representing the second order formed on the sheet of paper on the screen. Remember, n equals 2 means that the light from adjacent slits are out of phase by 2 wavelengths. So I'm going to magnify the circular part. And like I said, the light from adjacent slits is out of phase by 2 wavelengths. So the light from A travels 2 wavelengths longer than the light from B to meet and form the dot on the screen. Once more, AB is equal to D and AC is equal to 2 wavelengths. Again, if we use sine of theta, we get this formula when you rearrange it. So that means for n equals 2, the formula that describes the pattern formed from the interference of light is 2 lambda is equal to d sine theta. Now the same thing is true for n equals 3. I should have magnified n equals 3 there. So for n equals 3, we get that formula, and then we can turn around and say if it's true for 1, 2, and 3, then for the nth order, or for any order, we get the formula n lambda is equal to d sine theta. And you'll need all that for a proof if it's asked in the Leaving Cert.